Hello and welcome to Ms. Ma's Advanced Functions class. This is a supplemental lesson for 3.1, the cubic word problem that we did in class. So a cylinder is inscribed in a sphere and the radius of the sphere is 2. So it also gives us a couple more things. It tells us that this length right here is x and that this height is r. So this is the cylinder's radius right here. I'll just draw my cylinder in a little bit. You can see what it looks like. And this is a sphere, so my original diagram was a cross-section. And that's the sphere like that. I'm just doing some shading so it looks more 3D. Okay, so we've got this part of the diagram. It asks us for the volume of the cylinder in terms of x. So we're looking for v of x. And we know that the volume of a cylinder is pi r squared h, so we're going to have to convert the r and the h to be in terms of x instead of, r and h. So one more thing that we know is that if we start with the origin and we go to the edge of the sphere, this length is the radius of the sphere, so it will be 2. And if you look at the cross-section carefully, you can see that this is a right angle triangle. So I get a Pythagorean theorem relationship here. So I'll just write that out, Pythagorean theorem. According to Pythagorean theorem, the hypotenuse squared is equal to sum of the legs squared. So 4 equals x squared plus r squared. And I can see that I have an r squared here and I want to put it in terms of x, so I'm going to isolate r squared. R squared equals 4 minus x squared, like that. And I can put it into my equation. I also know that the height of this sphere is actually from here to here. This is x and this is also x, so the height is going to be equal to 2x. So I can replace all of those, or both of these, with x's. Pi times 4 minus x squared times 2x. And we get this from here, so we're just substituting it. Okay, and then we're going to put this in standard form, so it becomes negative 2 pi x cubed plus 8 pi x. And that is the volume in terms of x, v of x. Then it asks, asks us what kind of function is v. It is cubic. You can see that the degree is cubic. We expect most volumes to be cubic because they are 3D, so 3D is the cube, right? And then it asks us to argue that the negative values of x are reasonable, provided that we think of x as a coordinate. That makes sense because if we think of x as a coordinate, it could have gone down to negative 2, and then the other side would go up to 2, so it would sort of flip over this axis. So that is why negative values of x are reasonable. And then C, determine the roots of the function. The roots are when v of x is equal to 0, so we set that to equal 0. And I'm just going to use the factored form for that. We know that if any of these three factors is equal to 0, then the whole thing will be equal to 0. So pi can't be 0, but 4 minus x squared could be 0, and so can 2x. So we'll just solve for x in both of these cases. X squared equals 4, and therefore x equals plus minus 2, and here x equals 0. So these are the roots of the equation, and those happen when the volume is 0. So the roots occur when the volume is 0. Okay, and that's what it means in the context of this situation. If we want to think about the domain and range of that volume function, we know that, well, we couldn't extend past 2 because then we'd be outside of our sphere and it has to be inscribed on the inside. We also know that it can't be equal to 0 because then we'd have a cylinder of volume 0 and we don't want to have volume 0. So the domain for this volume is x in R such that negative 2 is less than x is less than 2, where x is not equal to 0. Or you could write it in this way as well, and it means exactly the same thing. X is in R such that negative 2 is less than x is less than 0, and 0 is less than x is less than 2. Actually, it should be or. So you can write an or here. Okay, and these mean exactly the same thing. Okay, so I did write a couple more questions for you guys in there on this page. So I would like you to pause the video and try it, and then you can come back and listen to me talk about it. Okay, so hopefully that you paused your video. I'm going to talk about A, B, C first, and then maybe you can pause the video and you can look at D separately. D is a much harder question. A pyramid is inscribed in a cube, so it looks like, and it's actually really hard for me to draw the cube. So this is the, this is the cross section, and if we draw the cube, it looks something like this. Right where that's the top there, and then we're just going to extend, so it looks something like that and something like this, and so we get this cube on the outside of it, and you can see that that's on the inside. So I'll just extend my lines right there, and then we get a pyramid on the inside, so that pyramid is touching the edge of the cube, and you can see it's touching the edges of the cube here. So it's going to actually end up being a square-based pyramid because you can see that it extends like that. It's going to go along the sides of our cube, and it has the vertex go to the edges of that cube. So this question, I just wanted to put it in to help you guys think about visualizing these 3D objects. You can see my you can see now my pyramid is inside of this cube here, hopefully, and that I've sort of got this flat piece on the inside. And so we're going to use the information that we have here in order to figure out what the volume might be. Let's assume that this is x again from the origin to the bottom of the pyramid. So this is going to be x. We know that this whole length is 2, which means that this is 1 above the axis, and below the axis as well is 1. Okay, so from up to here, so that the whole thing is 2. So that means that this whole thing as well, which is the bottom of the pyramid, is also going to be 2. Okay, that whole thing. And we also know that this is going to be 1 right here, along here. That's 1. Okay, so the volume of the pyramid is the base times the area of the base times the height over 3. The area of the base is going to be this length times this length, so 2 times 2. So area of the base is 2 times 2, which is 4. And you can see that the height of this pyramid is 1 plus x. So this is a pretty straightforward question. It doesn't have a lot of variables going on. V of x is equal to 4. That's the area of the base times 1 plus x over 3, and I could then expand it into standard form like that. It's a line. We could have negative values of x, of course, because x could come over here and just be a really short pyramid, so that makes sense. Determine the roots of the function in part A and explain the meaning of the roots. So x is equal to -1 is the 0 is the root of that, and that would mean that we had a volume of 0 for a pyramid. That's when volume is equal to 0, because we just have that 1 point, so that is the meaning of the root. Okay, the second part asks us a much more complicated question. How does the volume change if the center of the base of the pyramid is a secant of a sphere with radius 2? So instead of having a cube with side length 2, we've got a sphere, and that makes life much more difficult. Okay, so if you would like, you could pause the video. I'm going to draw a diagram, and then you can pause the video after that if you like, but it's a good idea to try to draw the diagram on your own, because that is probably the hardest part about this question. Once you've got a good diagram, you probably will be able to do the volume with less trouble. Okay, so here's me drawing the diagram. I'm going to have some axes. I'm just going to use my draw tool here. So I've got a set of axes, and I've got a circle, which is an unreliable draw tool. Ooh. So let me just move that over so that it looks centered. Yep, that's pretty good. And I'm also going to get the same kind of triangle. I'm just going to draw it out there and then just move it around for you. So again, I'm just drawing the cross section of that, and you want it to you want it to touch both sides. So I didn't do a good job of drawing a triangle. Actually, maybe I'll just draw my own with lines. So let's go with this black line right here. So it just goes up like this and down, so that this bottom length is going to be a secant. You can see it's a secant of that curve. It should be straight up and down. But my drawing is a little imprecise. That's okay. So this is the sphere. I'll just draw some shading in here. And then we've got this pyramid sticking out of it. So let me just redraw my pyramid. It looks something like this, where it's got, this is the base, but this is just the cross section of it. It should actually be sticking out of the sphere like this, so that it kind of comes out, so you can't really, you can't really contain it within the sphere. And then we get our vertex to the vertices of our pyramid. So it looks kind of like this. Okay, so you can erase the 3D-ness of it, and then it becomes a much clearer picture. You're going to use this as X, and of course this is half of the side length. Okay, I'm actually going to I guess I'll name that M. Alright, so why don't you guys try to solve that by pausing the video and going ahead. Okay, so theoretically you've solved it, and let's just see if you're right. From the center to the edge is going to be 2 as well. And I again know that my volume is going to be B times H over 3. Area of the base is the big B. So big B is going to be equal to 2m times 2m, so 2m squared, because it's going to be 2m, and then it's a square base pyramid, so 2m is along that way as well. And we also can see that we've got this right angle triangle again, so 4 is equal to m squared plus x squared. So in other words, m is equal to the square root of 4 minus x. It is not the plus minus because m is length, so we're going to call that just the positive version of that. So we can use these two pieces of information as well as the height of the pyramid. We know that the height of the pyramid is going to be this x plus this length from the origin to the edge of the sphere. It's 2. So the height is 2 plus x, and we can just fill that into our equation. So 2m squared, which is 4m squared, times 2 plus x over 3. We could have just left it as m squared there. If you like, you could have done that. So we'll just replace the m squared with our 4 minus x squared. So 4 times 4 minus x squared times 2 plus x over 3. So you can see that adding the spherical part of it changes it a little bit, but it just means that we can use Pythagorean theorem in different ways to figure out what the answer is. So hopefully this helps you out a little bit to visualize some of these different questions. You might try to use a different solid inside of our sphere, or you could use a cube or even a pyramid on the outside and see how that works out for you. So have fun, and I will see you in class.